Hello, Afton. Mr. Keith is back here on YouTube. Realize Pre-Calc has no videos, so I'm making you a video. Look at that. Look how special you are. Okay, so today's topic. Got to realize camera's on the table. Don't bang on the table. Just learn that. Okay, so today we're going to be talking about polar coordinates. I know you guys like titles, so here you go. Polar coordinates. I don't want anybody to yell at me saying, Mr. Keith, you didn't give us a title of the lesson. That's the title of the lesson. Okay. So, what are polar coordinates? So, I'll try to stop saying so. When we look at these problems here, we already have an idea of graphing on a circle. Ultimately, the idea of our polar coordinates is when we're looking at, I'm on the wrong side, when we're looking at a circle here, if I want to identify this point, where exactly is that point located? Now, we already have an idea of this based on this idea right here with our cosine of theta, comma, sine of theta. So if we know that this angle over here is 45 degrees, then we know this point here is simply located at the square root of 2 over 2, comma, the square root of 2 over 2. And actually, that's the accurate answer. I was thinking to not rationalize. You could have also said 1 over the square root of 2. That would have been the same thing. So when we're looking at these things, that's the main idea, is we want to figure out where exactly is this point located on the circle. So that was just the general idea of what we have going on here. Now, that was easy enough because, it was 45 degrees, pi over 4. We know that. So what do we do when it's something like this right here? And we want to figure out, hey, where is this point here located? Now, we could do the same thing. We could do the same thing here, and we could go ahead and we could simply turn around and say, well, we know that, that's cosine, comma, sine. So we could say this point is located at cosine of 20, comma, sine of 20. And that would be the ordered pair. That's how we all talk, right? When we say, hey, where's something located? Say, it's just at cosine of 20. No, we would approximate that. We would go ahead and but if you type that into your calculator right now, cosine of 20, sine of 20, we're going to see that's a really crazy decimal that we really don't want to write down. Who wants to write that down? I don't. You don't. So what we want to do instead is we want to talk about this idea of what's called polar coordinates, where instead of me identifying this right here, and this, when we're on the grid like this is what's called rectangular coordinates or Cartesian coordinates. Again, unless you're on Jeopardy, those were, again, Cartesian doesn't mean a whole lot, but yeah, it's called rectangular coordinates because, we're on a square. We have a bunch of squares here. I could say, yeah, I went over so much and up so much. But when I'm not on these nice, pretty points right here, when I'm not on what we call these lattice points, it's hard to identify a lot of these points. So many times in math, we want to come up with different ways for us to talk about identifying it. So the one way to talk about identifying it is with what's called polar coordinates. So instead of me simply talking about, hey, like this is located at cosine of 20, comma, sine of 20, a lot of times what I'll do is I'll identify this in what we call r comma theta. More on that in just a few minutes. So as we look at that, r is simply the radius of the circle that we would be on, and the theta is the angle in which we're looking at. So right here, if this was the unit circle, we just know, hey, this has a radius of 1, and we're going 20 degrees. Now, for today, just because, we're learning this virtually, we're going to go ahead and simply use degrees. In reality, we should be using radians, but I'm trying to make life easier on those like playing at home. So, but that's the idea, is now we can identify this point is just located at 1, comma, 20 degrees, which is basically the idea of, hey, we're on a circle with a radius of 1, and we're just moving 20 degrees along the side of that circle. Now, if you were to go ahead, you could Google polar grid, polar graph, and you would see kind of a bunch of circles with some axes and angle measurements and all that stuff. Again, feel free, you can pause this video, Go Google that. Okay, we know you didn't Google it, but still, that's the idea of what's going on. And then we can expand that idea to say, hey, well, what if we're not using the unit circle? Forgot a question mark there. What if we're not using unit circle? What if we have a circle with a radius of 1 and we want to start identifying a radius of 2? Why did I say 1? A radius of 2, and we want to start identifying points that exist on that circle. Well, to help us do that, this is where we can start using this idea of this r comma theta, where we have these polar coordinates. So you can see right here, I was like, we write our polar coordinates as r comma theta. R is simply the radius of the circle or the distance from the origin. If I were to go ahead and just draw a line from the origin to a point on the circle, what would that distance be? That's ultimately what we want to figure out. That's what our radius is. And then the theta is just the angle that we're opening. So we've been talking about, angles in the unit circle, and all that stuff. Now we're just expanding this beyond the unit circle, and we're looking at things like this right here. So give you a second, finish copying that down. You can pause the video to copy it down too, so I don't know why I'm pausing. All right. So with that idea in mind, if I wanted to go back to this previous problem that we have right here, and I said, hey, there's some point that's located right here. And I wanted to say, hey, what's the ordered pair for that point? That's a really hard thing to do in rectangular coordinates. But if I just said, well, you know what? I know this has a radius of 2, and I know that this angle right here happens to be 80 degrees, then I know that point right there is simply located at 2, 80 degrees. That's simply what the idea of polar coordinates are. I'm going to go ahead and, again, think about the idea of being on a circle and think about, hey, what angle did I open it up? And that's all we have for polar coordinates. So if we wanted to graph this right here, 6, 120 degrees. That's a little bit tough here. But ultimately what I would need to do is I would say, okay, well, now I was using, to make the circle bigger, I'm going to go ahead and say, okay, well, I got to think about being on this circle right here. You guys already know my circles are terrible, but I got to think about being on that circle right there. And then I'm going 120 degrees. So that would be, well, we know that's past 90. Again, it's going to be a little bit tough on this Cartesian plane. I don't have any polar graphs to show you right now. But again, I told you Google it. You're not going to, but I told you to Google it. So right here, I'm going to go ahead and 120 would be probably about there, I would say. So yeah, 6, 120 degrees would just be located right there. Now we could also, again, just because I want to talk about radians, yeah, we could also see 6, 2 pi over 3. And honestly, to me, when I see that, yeah, I could convert that to 120 degrees. That's definitely something we could do. Or I could just think about it, well, 2/3 pi. Well, pi is all the way around. So if I were to cut this into thirds, that being 1/3, that being 2/3, yeah, I could just go ahead and say, yeah, that's 2/3 of the way, halfway around the circle. So that's really how I think about it when I'm looking at radians there. So that's the idea of graphing. And if you look at your homework assignment, you have a few of those problems where you have to graph. And you can see on the homework, I gave you some polar graphs just so you can see what those polar graphs look like. But now what if we had the question, well, hey, you know what? Where's 3, -4 in our polar coordinates? Where is that located? So if we want to figure out where exactly that's located, conveniently, some stuff got erased on the back, we can go ahead and we actually have little formulas to help us convert this. Now, as you look at these formulas, hopefully a few of them look familiar. So as we look at this top one here, if I'm going to convert from rectangular coordinates to polar coordinates, we have r equals, I'm getting a glare here, sorry. We have r equals the square root of x squared plus y squared. For those eagle-eyed geometry students, we can tell that's just a modified version of the Pythagorean theorem. That's all we have here, because we're talking about circles and making triangles and all that stuff there, because that's all trigonometry is. It's a bunch of triangles. Now, our theta is just y, or the inverse tangent, sorry, of y over x. Why is it y over x? Well, let's stop again. If I were to go ahead and think about making a triangle from in the unit circle, just like we would, well, we could see that, again, it's simply the y's are the up and down. That would be the opposite. I was like, the x value would be the adjacent. Or we can use the definition that tangent is sine of theta over cosine of theta. If I go back to pulling it up, this right here, hey, sine of theta over cosine of theta. Sine is my y value. X is our cosine of theta is my x value. Hey, look, that matches up perfectly with the definition of tangent that we've already talked about, or I should say the identity of sine over cosine. Now, if we want to go the other way with it, if we happen to know the polar coordinates, but maybe we want that rectangular coordinates, maybe we want to call that, say, hey, what's that in x comma y? Then we can go ahead and use r times cosine of theta, excuse me, and y equals r times sine of theta. Once again, that matches up with the idea that we already looked at in the unit circle. Just now we have to multiply by that radius. So that brings us back to right here. That brings us back to this idea of saying, hey, where is 3 comma negative 4 in our polar coordinates? So if we have this right here, so 3 negative 4, so 3 negative 4 would be right here. And I just realized one thing I forgot to say going back, but 3 comma negative 4 would be down here in this quadrant. So we can simply go ahead, and the radius is just the square root of 3 squared plus negative 4 squared. Now, remember, as we're typing this into our calculator, if I'm squaring a negative, that should always be positive. If your calculator says something negative, you're doing something wrong. So 3 squared is 9 plus 16, square root of 25. So we know that r equals 5. So we know in our polar coordinate, it's 5 comma something. Well, to figure out that something, we can just go ahead and we have theta equals inverse tangent of negative 4 over 3. Now, at that point, we just let our calculators do the work for us, because that's not going to be the prettiest of numbers. So inverse tangent of negative, I hit the minus sign, negative 4 divided by 3, close that up. We get negative 53.1 degrees. That's what we get there. Now, the thing I forgot to mention, when we talk about our theta, we could say that negative. We could do that, but most of the time, we like this theta right here to be between 0 and 2 pi, or between 0 and 360 degrees. So go ahead and go back to your notes and add that part, because that's where we typically like that to be. So if we got an answer of negative 53.13 degrees, how could we figure that out so it's in between 0 and 360? Yeah, what's you in the back? What did you say? Yeah, you're right. Add 360. Good job. Yeah, we can just go ahead and hit, since it's not in between 0 and 360, we can just go ahead and say plus 360, and then we can see, oh, That's 306.86 or 87 if you want to round it. We're not going to get too picky. So yeah, so this is located at 306.8, I'll say 87, it's close enough, degrees. Now, because we're not using radians, we do have to make sure, do not forget that degree symbol when you are writing that. Like I said, something you got to make sure you got that. But yeah, this right here, this point would be located at that in radians. So that's, again, a powerful thing for us to go ahead and for us to look at. So with that in mind, now that we've looked at an example, I want you to go ahead and convert to polar, and you can go ahead and you can convert to rectangular coordinates as well. So I would say go ahead and pause this video right now. Great, glad you paused it. So hopefully you were doing those problems while you paused it. I mean, you might have gotten a snack, but hopefully you did these 4 problems while you paused it. So with that, yeah, we can go ahead and to figure out the polar coordinates, I know that, hey, my r is located at the square root of -5 squared plus 12 squared. Now, I'm just doing the math real quick in my head. I know that that happens to be 13. So that was a nice, easy, pretty number for us. Radius of 13. And then we still have to figure out our theta is simply inverse tangent of 12 over -5. Now, there's something for us to talk about here. Because when you look at this, what's going to end up happening here is that if you type that into your calculator, you're going to get a negative angle in the 4th quadrant. But if we look at -5, 12, well, -5, 12 would be up here in the 2nd quadrant. So that doesn't make sense. Well, that's a limitation of our calculators. Our calculators are only going to find answers for us in the 1st and 4th quadrant. So what do? How do we figure out what we need to do? Well, here's the nice thing is that because it's tangent, I was like, the point up here and the point right here, I was like, are mirror images of each other. So the only thing we have to do when we go ahead and we say that inverse tangent, let me use my calculator real quick, inverse tangent of 12 over -5, we get -67.38. -67.38. All we really have to do here is go ahead and add 180. If you add 180 degrees to that, that will actually shift from being here to up here. So that's a really nice thing, is that if we're in the wrong quadrant, all we have to do is add 180 degrees to get to the proper quadrant. So once again, add 180. So we end up with, this point is located at 13, 112.62 degrees. Then we can do the same thing for this one. Our radius, now I'm just doing the math real quick in my head, ends up being the square root of 41. If you didn't get that, go ahead and leave a like down in the comments or whatever the YouTube people say. I don't know. But yeah, go ahead, ask me. I can point that out. But yeah, we get the square root of 41, and then once again, if we go ahead, even if we did inverse cosine of -5 over -4, that's going to give us a positive angle. So that's nice. But that positive angle is in the 1st quadrant. Once again, if I look at -4, -5, well, -4, -5 would be down in the 3rd quadrant. So if I take the inverse, real quick, inverse tangent of -5 over -4, we end up with 51.34 degrees. But once again, I want this guy. That would be in the 1st quadrant. So I need to go ahead and add 180 degrees. I hit times on my calculator. Crud. add 180 degrees. Can I say crud on YouTube? I don't know if I can. Better than some other things I could have said. We have 231.34 degrees. Now, as far as converting to rectangular, that's the easy thing. We go ahead and just use the other one. Hey, I know x equals 6 times cosine of 150, and y equals 6 times sine of 150. That's all I got to do. It's a lot more straightforward to convert from polar to rectangular. So that is the kind of nice thing there, where it's not as tough. Once again, we let our calculators do the work for us. 6 times cosine of 150. So we end up with a negative 5.19, which it's a 0.196, rounded at 0.52. That's fine. Or again, that's option one. And right now, I'm not upset if you were to use those decimals. But because this is a nice pretty one, we can actually say, well, wait, cosine of 150, we did that on the last test. We know that that's just negative square root of 3 over 2. So we could simply go ahead and say, hey, x is located at negative 6 square root of 3 over 2, which simplifies to be negative 3 square root of 3. So that's our x value. Sine of 150, that's actually just 1/2. So 1/2 times 6, we end up with 3. And when we think about it, that makes sense that we'd have a negative then a positive, because, yeah, 150 would put me in the second quadrant. And if I graphed negative x comma positive y, that would also be in the second quadrant. So again, these things make sense when we start to think about them. Same thing down here. Hey, x equals 3 times cosine of 200. Y equals 3 times sine of 200. Now, this time I did pick some angles that were not our nice, 30, 45, and 60. So right here, yeah, we will need to use a calculator for this one. So if I do 3 times cosine of 200, I get negative 2.82. And then 3 times sine of 200, we get negative 1.03. So yeah, this time we did have to approximate just because they weren't those nice, pretty square root values that we're used to. And that might happen from time to time, where you just kind of have a number that you have some numbers that just aren't as pretty as we'd like, and that's okay. So with that in mind, that's all I got for today. Just wanted to kind of make sure that we're introducing polar coordinates. Again, there is a worksheet. Make sure to be working on that worksheet. That's all I got. So if you have any questions, go ahead, shoot me an email. I'll be in the chat, or not this chat. I was like, I'll be in the Google Meet all day. So with that, that's all I got. So I'll wrap this up. Stay safe out there, Afton.